Hi, my name is Professor Terry Meyer-Boak. I teach at the School of Architecture at the University of Waterloo, and I am part of the CISC Education and Research Committee. And I want to speak to you today about our next student design competition called Ascent. And our topic is When Steel Meets Height, Adventuring into Ascent, the 2024-2025 CISC Student Design Competition. The topics that we'll look at today talk a little bit about the current competition. Secondly, we'll look at using architecturally exposed structural steel in these design projects. We're going to unpack some previous competition winners to find out how they did it and what their approach was. And lastly, we'll look at what it does mean to build tall with steel. So the current competition is called Ascent. And what we are asking you to do is to look at applying steel to the design of an experiential project that investigates ascending. Rather open, intentionally. It's to be located in Canada to the discretion of the specific teams. Our first prize is $8,000 with a faculty sponsor receiving $2,000. Second prize, $4,000. Faculty sponsor receiving $1,000. And the third prize, $2,000, faculty sponsor receiving $500. And the winnings are divided amongst the team members. Submission deadline is May the 16th, 2025. Full information is available on our website. Eligibility and jury. The eligibility is open to students in schools of architecture and architectural engineering across Canada in degree programs. The jury includes people from all parts of the industry: architects, engineers, fabricators, and educators. They know steel, and they have been selected because of their passion and interest in steel, specifically looking at exposed structural steel. So you need to show them that you know steel too, and that you are adept at designing and pushing the limits with it, and maybe even love it a little bit. One of the things to note is to be sure not to include your names on the panels or you will be disqualified. So, a little bit about architecturally exposed structural steel. This is a steel competition, and the steel will predominantly be expected to be featured, therefore exposed. So please review the presentations on the competition website for a full explanation of the CISC AESS specification method so that you can note it on your presentation boards and it can be used to influence your designs. The jury will want to see clear connection detailing, bolts or welds, member types, etc. And looking at these presentations that have been supplied will really help you in understanding how to apply steel to your projects. So what is AESS? Architecturally exposed structural steel is steel that has been purposefully left exposed. It has to fulfill structural functions, and it is normally part of the architectural aesthetic of the space because it's exposed. It usually requires detailing, finish, and handling that requires more attention and care than regular structural steel, and it will add to the cost of the contract. Thankfully, in your projects for your competition, we are not asking you to provide a budget. So what are the primary factors of influence for AESS that were used to describe and define the CISC specifications? Well, we're very concerned about distance and visibility because the closer the steel is to you, the more you can see and understand the finishes and the details that you have described for it. It'll depend whether the connections are mostly bolted or welded, and that would be left up to your discretion. Both can be done equally strong. Tolerances that are required at fabrication and erection are a lot tighter than regular structural steel. And the access has to be there to perform the required finish and details. A big thing for you would be looking at the degree of expression. So that has to do with the size and the shape of the structural elements, which are choice-wise completely up to you. In a professional situation, we have to be concerned with the interior or exterior setting because that's going to affect your paint finish, your corrosion resistance, and your fire protection. So the core idea is form, fit, and finish. And so one of the reasons that we created the specification was to be able to differentiate the detailing approaches to, say, two trees, as you can see in this image. They're both architecturally exposed structural steel, but each is quite different from the other. So why would the AESS specification be even remotely the same? And so the sense of these images is to suggest that even when we describe a requirement or a title for the competition, there can be many, many different approaches to arriving at a solution or a suggestion for that. So the connection types are really important differentiators. Here you can see a choice of bolted connections, pin connections, welded connections, each structurally doing whatever it needs to do, but they give you quite a different aesthetic. And so when we're looking at the competitions, we need you to get into really specifically the nuts and bolts of how your project goes together to show that you have a really good understanding of that and that you can begin to explore and exploit it. The coating and protection systems need to factor. So this is something that would be more likely to be pursued in detail on a professional project. But nonetheless, if your project for Ascent is going to be an exterior application, you might want to consider how you're going to protect it for corrosion or what kind of finish you're going to put on it, but also that that's going to either mask or enhance some details and work differently with different kinds of connections. For example, if you go for a galvanized coating for corrosion, it doesn't make a lot of sense to do highly polished, finished, welded connections. So you see that the galvanized one has bolts, whereas some of the ones that are given a paint finish might have gone for a bit more welding. So the connections and member types then equal aesthetic decisions. And so this is a motivated project in terms of the design competition. And so your choice of members and details is going to feed very directly into the final resolution of your projects. So these aesthetic decisions become project drivers. Here you can see three completely different projects taking different approaches to the choice of members, the shape, the connection detailing, and the use of light. So to dip quickly into the CISC AESS method, again, a lot more information is on the competition website for you to look through. We've divided it into basically four primary classifications of AESS. We start with standard structural steel on the right, which is steel that goes to CSA S16 for its specification. And then we ramp up to basic elements, feature elements closer, showcase elements, and then custom fabrication. So we use this matrix in order to describe the relationships between the categories and the characteristics. So one of the things that was a motivating factor when we defined and created the specification system was trying to prevent unnecessary welding on the project for welds that would be taken away and smoothed out. So we realized that if you were looking at something at a distance, that you could perhaps just leave the welds alone, do them nicely. If you're looking at feature elements up close, then maybe you want to grind those welds, but not even all the time. So down the left-hand side, we have characteristics. And as you go through the entire requirements on the competition website, you can see how these are ramped up and cumulative from AESS 1 down through AESS 4. And the fabricators provided us with estimated cost premiums, which of course increase as the detailing and the finishes become more particular. So we start with standard structural steel, which is our initial point of technical reference. And so it is unlikely that you will use this in your competition entry, as this kind of structural steel is normally concealed. The first category would be basic elements, the first step above. You might find this in a big box store, something that would be on the ceiling of, say, a recreational facility. It's also unlikely that you would be using this category because it's fairly basic and just sort of cleanly done. AESS 1 basic elements. Here again, you can see a step above, regular structural steel. It's a little bit better spaced, and it's quite functional in many applications. AESS 2, we start to look at feature elements that are at a distance of greater than 6 meters. And so we're going to be using the first two sets of characteristics associated at the left. And here we can see that a lot of this would be used on skylight framing, roof framing, materials that are quite nicely exposed, sometimes supported glass. And you might be finding this category somewhat useful for your projects for materials that are located at a distance. AESS 3, which is feature elements viewed at a distance closer than 6 meters, is likely to comprise an awful lot of what you will be using on your projects, because everything that you would be viewing as you would be climbing or ascending your structure would be viewable close up. And it includes all three sets of characteristics that you can see on the left. And so very often we find it traditionally used in places like airports, shopping centers, museums. You might find some curved steel here. It allows for weld grinding to clean up the aesthetics of the connections. And then the top category would be AESS 4, which would be showcase or dominant elements. And this includes the complete set of characteristics at the left. And it's very special. It signifies something very special is happening with the steel. It's not to be used indiscriminately by architects if they're unsure about requirements and want to be safe. It will incur significant cost premiums. And if you want to create custom elements, this is useful in your competition entries, because we're using materials like plate steel. We're making things from scratch. We're not using standard structural elements. And also to note, if you're using stainless steel and weathering steel, they also fall into this kind of category because they have very different physical properties because of their chemical content. So again, here's some examples of some showcase elements in buildings where AESS 4 has been used. Again, you can see curved members that are made out of plate steel, members that use large custom castings. And all of these would be quite applicable to anything you would be pursuing in terms of your competition entries. So how do we create a winning set of boards? All of the following projects that I'll show you have received an award of excellence in the past 10 years in the competition. The entrants range from year 1 in an undergraduate architecture program through to Master of Architecture students. So the year or level you are at your university or in your program doesn't necessarily impact how well you can do in the competition. It depends on your intentions and the way that you work your projects through and present them. These projects included herein were undertaken independent of a design studio. So you do not necessarily have to do this project in conjunction with a design studio. All of these were final projects for half-credit technical courses, but it is quite possible to undertake the project on your own, independently, with or without a faculty sponsor. These works were largely done independently, though, and without formal critiques from the faculty advisors, but this will vary by institution and advisor. Some advisors have more availability to give you critiques and criticisms. You're also encouraged to go to a local architect, engineer, or fabricator to receive some feedback on your project as it's in progress. But these all use a complete range of drawings and include very credible and very well articulated details. The review of the boards happens in an online environment, so be sure that everything you include is very clear and able to be read on a screen. We highly recommend using a landscape format because the jurors are using computer screens, which are typically horizontally oriented, and so it saves them a lot of zooming in and out, and it also makes the boards appear more in keeping with the viewing mechanism. So on this particular board, again, it won an award of excellence. I would say that the text at the top is a bit small, and on a first pass, it's very important that your first board is going to make a good impression on the juror and pull them in to look at it a little bit more closely. Again, the requirement, maximum number of boards is 3, and I find that most of the people who enter the competition use 3 boards. So on the second and third board, you need to complete the picture. If the first board is the money shot and the one that draws the jury in, The next two boards have to completely explain the project. So your plans, your sections, your elevations, your renders, and details. And you'll find that most of the winning projects will take an axonometric of the project and pull apart and show where all the detailed connections come through. This board is also showing on the bottom of the right-hand side all of the different materials they're using, as well as looking at the AESS categories. So those are clearly explained as well on the board. This next project, called Market on Ice, was done actually by a team of first-year students. So what can you add that maximizes the impact or versatility of the design? Everyone is doing the same competition, but all of the entries look quite different. And so it's your take on the theme and how you want to describe that, or sometimes expand upon it, because you need to have some sort of an edge on other entrants in order to make your project stand out. So on this particular board, they've looked at the canopy project in terms of the idea that it could be used in the summertime for one purpose and in the wintertime for another one. Again, on boards 2 and 3, they're making a coherent set, including details, renders, and I think that these boards are really nicely balanced in order to give a complete view, a complete understanding, as well as making a very sort of compelling presentation. You need to annotate sufficiently to explain the use of the steel. This board takes you into the project and clearly makes a connection with the theme. So it's really one shot, but also includes on the side its location and site plan. Site plan is quite small because in a project like this, it's the detailing and the sort of understanding of the three-dimensionality of the materials that's probably more important than the siting issues. And so here, boards 2 and 3 complete the set. One of the things that was fairly innovative was the cell phone shot that she included on the left, showing what it would be like to experience the project. And so you'll find that a lot of the renders are not only renders that show you the project from outside the project, so you get a good overview, but a lot of them are also the view of an occupant inside the project. And so this idea of showing you sort of the experiential qualities of the projects become really quite important, I would say, in compelling the jurors and leading to a winning project. Again, on the right-hand side, you can see clear detailing for all of the connection details, as well as she describes the AESS categories. This particular project did a value add. What did they want to add special to the program so that your project will be set apart and above the other entries? This set of boys looked at water collection for Africa. And so they designed a tower project with a bridge going across that had a water collection mechanism that would take the night dew and create water collection so they would help the locals. And so in addition to giving us a clear set of details, drawings that showed all of the required orthographic views to make it really understandable, they also went into quite a bit of work to understand the water collection system and explain that on the right-hand board. This particular board, which was for a market, chose to make a more complete statement on the front versus a single sort of money shot. But the team that worked on this spent an awful lot of time looking at making this into not only a market that would be a pop-up, but also a pop-down market. So they looked at design for disassembly. And so a lot of the space on the second and third board was taken to, particularly in the left-hand exploded axonometric, showing how the entire set of stands for the pop-up market would go together and as well come apart. And then the details on the right-hand board are extremely well crafted and show very particularly how everything is going to go together as well as come apart. So again, I think one of the reasons that pushed this particular project to the top was the extra effort they made to fully understand the mounting and demounting of the project. So part of what we get into in detailing is showing that you have an understanding of how steel projects are put together. And again, the views were very sort of experiential, so you could really feel what the space was like to inhabit. This particular canopy on the front page here, it includes your money shot, as well as some explanation and some of the line drawings. So that's board 1. And then boards 2 and 3. One of the things that a lot of students like to do is show daytime shots and nighttime shots to give you, again, more of the idea of the experience. This was a performance space, and obviously a lot of performances would also happen at nighttime. And so they were, quite careful to show how the entire assemblage went together, as well as how it would feel when a performance was happening. So you can see there's quite a lot of density and information in these boards. This particular one was a bridge project, and so this was actually supposed to be at the border of North and South Korea, and so it was more of a political statement by the student that this is not a bridge. So it looks like a bridge, but when we look at the detailing of it, there's this this separation between the two ends of the bridge. But on the left-hand board, an axonometric that shows clearly how everything goes together, differentiating between the tensile support system and the more compressive systems and the spanning systems that are necessary to make this one work. So what about our competition theme, ascent? The noun, or the word ascent, actually is a climb or a walk to the summit of a mountain or hill from the dictionary. So our theme this year is an experiential action and not necessarily a building type. It infers a destination, maybe with a view, and it's intentionally pretty open. So the photo that we selected for the poster on the right-hand side here is a spiraling staircase that goes up to the sky. Some other ways that we could look at that would be the ascent, sort of a more classical building in the middle, or a more contemporary staircase system on the left. But the idea is that this is not an interior, but this is a freestanding building structure that you are charged with the design. And so the idea about ascent is that it's experiential. It's about the climb. So everything that I've said to you about the previous boards comes through in terms of how do we make this a means? How do we get to the top? What is it like to get to the top? How are we using steel in order to make that happen? But the ascent must be inclusive. Experiences are not just for the able-bodied. So you must provide an alternate and equally interesting means of ascent that can be accommodating for the mobility challenged. That would include people on wheelchairs, strollers, or scooters. And this is really important for you to understand because a lot of buildings may also provide an elevator access to the top, but it's an enclosed elevator that you go up and you could be in an office building, and it's really not the most exhilarating experience one can have. And so that asks you to look a bit at vertical transportation methods. The picture on the left is a view up the elevator shaft of a tower in Fukuoka, Japan. And on the right is the view looking from that glass elevator out through the structure of the tower to the exterior. So as far as an engaging experience, it was a pretty engaging elevator ride that was actually the only way up this tower. We weren't allowed to climb up the stairs. So we want to experience the steel itself. So from the inside of the building as we ascend, from the outside of the building as we look at it. And if we look at the way towers have been done in the past and buildings that make exposed steel to height, we can see some of the older towers use more lattice structures. On the right-hand side in brown is the Eiffel Tower, which is probably one of the earliest steel towers. And on the left are some examples from Japan, showing the use again of lattices on some of the older ones and some tubular steel on some of the more contemporary projects. Stability. We can go for traditional stability. So there's me with my family in front of the Sapporo TV Tower, which is one of the many towers that was constructed in Japan, mostly of the same sort of A-framed model, which is loosely based on the ideas that were put together by Zhukov in Russia at the early 1900s with his towers. And so we can look at that as sort of the model for stability, or we can look at more challenging and perhaps more exciting modes of going to height, creating an ascent that may deal with eccentric loading. So the one on the left is the Capitol Gate office building in Abu Dhabi, which it's a 18-degree backwards lean. And so it has to have a lot of counterbalances in terms of the core in order to tension it and balance so that it doesn't actually fall over. And the middle one is the Orbit Tower, which was done for the London 2012 Olympics. And again, it's all made out of prefabricated steel pieces that twist around. And so there's also an interesting spiraling climb and staircase to take you to the top of that tower. And then on the right is Heatherwick Studios' vessel in New York City, which has stairs to permit climbing to the top, although the ascent for the people who may not use the stairs is really an enclosed elevator just off to one side, so not quite as an exciting experience. So ultimately, the ascent is really maybe about the view. What do you do at the top? How do you engage with the landscape? How do you look through the steel? How do you look over the steel? Again, the site and location can be selected by the team themselves. We're leaving that quite open. So for questions and additional information, the full competition details are available at the competition website. Be sure to check out all the resources to help you better understand how to make the best use of steel in your projects. So there's some educational videos that I put together, which are available through the link on the website. And on the right-hand side, this is what it takes you to. So you can see there's a series of videos ranging from about 9 minutes to 15 minutes, which will take you through different topics in terms of the basics of AESS, finishes, ideas about connections, custom connections, how to do tensile structures, and how to deal with span. And also there's another website at the bottom called Fun is in the Details, which takes you through all sorts of additional information on steel construction. And with that, I say thank you very much. Please feel free to email the competition website if you have any additional questions, and thank you very much for your time.